Welcome back to Engineered Coffee. This is Anthony Kay. In this episode, we are going to discuss grind size distribution and why it's never uniform. The question is, what is grind size distribution? When you grind coffee, you don't get identical particles. You get a mix. There are large particles, often called boulders, medium particles, the main body, and very fine particles called fines. This spread of particle sizes is called the particle size distribution, or PSD. Even the best grinders in the world produce a distribution. Uniform grinding simply does not exist. And you may ask why this matters for extraction. Different particle sizes extract at different speeds. Fines extract very quickly. Large particles extract more slowly. So when you brew coffee, you're not extracting one thing. You're extracting multiple layers at the same time. If the distribution is too wide, you get over-extraction from fines, which would make it bitter, and under-extraction from large particles, and that'll make it sour. And those two things can exist in the same cup. Why perfectly uniform grinding is impossible. Grinding coffee is not like cutting metal. Coffee beans are brittle, irregular, and anisotropic, meaning they break differently depending on the direction of the bean. When a bean enters the grinder, it fractures, not cleanly, but randomly. Each fracture creates multiple particle sizes, new fracture surfaces, and more fines. So every grinding process is a balance between breaking the bean and controlling how it breaks. So another question is why we use roller grinders. This is why high-end coffee production uses multi-stage roll grinders, like the systems from modern process equipment, for example. Instead of grinding everything in one step, the process is staged. Each stage reduces particle size gradually, controls fracture behavior, and limits the creation of fines. And importantly, each stage is water-cooled because heat changes everything. So why temperature control is critical. If the grinder heats up, you get problems because metal expands. If your roll gap is, say, 300 microns, with rolls of around 200 millimeters in diameter, and cooling fails, thermal expansion can reduce that gap. Best case, your grind shifts out of spec. Worst case, the rolls touch and you get a crash, which is not a small problem. It's a serious failure. The next step in the process is the role of the densifier. After grinding, another critical step is the densifier. It is often overlooked. The densifier compacts the coffee, stabilizes the bulk density, and improves dosing consistency. Because in capsule filling, you're not just controlling grams, you're controlling volume, flow, and packing behavior. If density varies, everything downstream can become unstable. So why we constantly monitor the PSD, particle size distribution. In our case, we use laser particle size analysis every 30 minutes because small shifts in the PSD can have huge effects on extraction time, pressure profile, crema formation. We're not just measuring for curiosity, we're measuring for control. And then we have transporting the coffee. Even after grinding, the job isn't finished. Transport matters. If you move the coffee incorrectly, the fines can separate, larger particles can settle, and the distribution changes. That's why we use systems like chain conveyors. They transport the coffee gently from the grinders to the filling machines, preserving the particle size distribution from the grinder to the filling line. Because once PSD changes, everything changes. So the real goal is control, not perfection. The goal is not to perfect uniformity. That's impossible. The goal is controlled distribution, a PSD that is stable, repeatable, and optimized for the brewing system. Because coffee extraction is not about precision in one variable, it's about the balance across many. So the next time you hear someone talk about grind size, remember this. There's no single grind size. There is only a distribution. And that distribution is one of the most important and most invisible drivers of coffee quality. This has been Engineered Coffee. See you again next time. Please like, subscribe, and share.